Hello friends and welcome back. So in the previous two sessions I have covered the LLMs and the RAG. Okay, and in this particular session I am going to cover other critical topic which is the embedding and vector databases. So before I move forward, let me quickly give you a recap of what are LLMs and what we have learned about the RAGs. Okay, so LLMs, sorry, let me enable. So LLMs are called the large language models. Okay, so this model is trained in a huge amount of data. Okay, there is a huge amount of data. Okay, and LLMs are trained on this huge amount of data. So this data is the available on the public domain. Okay, that means it is not your personal data or it is not personal to any organization. This is the open source data which is available on the internet or public network. Okay, and these LLMs are trained on this particular huge data. Okay, and then whenever we train an LLM on this data, we generate a new model. Okay, for example, there would be a 4.2 model, then there would be a 5.2 model, 5.4 model, something like that one. Okay, so these models are nothing but it is a models that has been trained on the humongous data. Okay, and what we learn about the LLM, it is specifically trained on the publicly available data. Okay, now when we talk about the RAG, retrieval augmented generative, so we have a limitation in the LLMs. Okay, because it only work on the data which is publicly available, but not specific to individual to you or maybe your organization, right? Because if I suppose I ask what is my organization's leave policy, how many leaves are allowed in my organization, your LLM will not able to answer that one because that data is not available in the public. That is specific to your organization. So that is your internal documentation, right? Your organization's internal documentation, and LLMs are not aware about that one because the LLMs are not trained on your organizational personal data. Right? Similarly, if I ask what was my grade in the graduation, okay, so LLM will not able to answer that question because that data is personal to you and that information is only with you, right? The document, your certificate is only with you. It's not with the LLM. So LLM has not been trained in your personal data, so it's not able to answer that particular question, right? So now to overcome that limitation, okay, we have a RAG, retrieval augmented generative. So in RAG, what we do, in RAG, we get the real-time information from your own personal database or maybe from your organizational personal database. Okay, to respond to the customers, to respond to your internal stakeholders, okay, on the specific query that is related with only you or maybe with only to your organizations, right? So that means suppose that I am going to create a RAG, okay, and this RAG is going, I'm going to give the access to the RAG, my organizational data. Okay, and there would be a policy document, leave policy document PDF. Okay, so now I have given the access to RAG to fetch my internal documents, right? So now if I will ask what is my organization leave policy, okay, so now RAG will have the access to my personal organizational data. Okay, so it can easily understand this document and can give you the answer. Right. Similarly, if I suppose that I have given access to my personal data, I have given to my all the certificates and mark sheet that I have earned, okay, in my uh, learning phase. Okay, so I have given access to all the certificates and documents to the RAG. So now, if I will ask what was the percentage I secured in my graduation, okay, so now because RAG will have access to my personal data, so it can read my personal data certificates and then it can give you the answer. So this is the limitation with the LLMs. This we can achieve with the help of RAG. So basically RAG we use when we give access to the RAG to some specific data. It could be your personal data, it could be your organizational data. Okay. So this is a RAG and LLM that we have learned so far in the previous session. So now when we are going to learn the embedding and vector database. Okay. So this embedding and vector data is specifically related with the RAG. Okay. So how when we run the query, so how this particular data, I'm telling that this is my organizational data, okay, which I am going to provide access to the RAG. Okay, so how this data is stored and where it is stored and which form it is stored. Okay, it will not be in the simple PDF form or it will be not in the simple database access. Okay, so whenever you configure the RAG, okay, we have a specific database like we can vector database. Okay, and inside the vector database, we store all this data in the form of embedding. Okay, it will not be in the generic format. Okay, like we have a document in our file system and we run the search command, then search command look for that particular text in all the documents that is available in the current directory, and then it is going to retrieve the documents. Okay, this not work in this way. Your rag is not working that in that way. Okay, so whenever we provide access to the rag for any of our organizational data, okay, it is going to store in the vector database, and whenever we search the vector, whenever we run any query from the rag, okay, like suppose I'm telling what is my company policy on the leaves. Okay, it is not going to search for the PDF, it is going to search for the vector database where the data, this complete data is stored in the form of embedding. Okay, and that is what which I am going to explain in this session, how this embedding and vector database works. Okay, at least you will get the some basic understanding of all these fundamentals. So now very first thing, embedding. So we have two things, embedding and vector database. The very first thing I said, the important part is embedding, because in the vector database, the data is stored in the form of embedding. So what is the meaning of embedding? Okay, so embedding, you can think of it like a map, right? Because we know each city has GPS coordinates, right? Each and every city in the world has a GPS coordinate in the form of X and Y, right? X and Y, GPS coordinate. So cities that are close on the map have similar coordinates. Embedding do the same for words and sentences. They turn meaning into numbers. Now, what does it mean? Now, suppose that New Delhi has a coordinate of 28.6, 77.2. Okay, so any city which is nearest to New Delhi, okay, will have the coordinates similar to this one or maybe near to this one, like 28.6 and 77.2 is for Delhi. Now, if I talk about the Haryana or Gurgaon, okay, so Gurgaon may have the coordinates something like 29.5 and then 78.2 or something. This is just I am giving for a reference that it is nearest to New Delhi. The coordinate will be nearest to the nearest city, right? Similarly, when we save the data in the vector database, okay, it is stored in the form of vectors. Okay, and what does it mean? That means embedding do the same for words and sentences. They turn meaning into numbers. So what we do exactly, like here the New Delhi is referenced by the coordinates, by the numbers, right? The text is referenced by the number. Similarly, in the embedding, a text is referenced by the number, similar to this. Only one thing, in this embedding, the text is not specifically to the only two coordinates or two numbers. So here you can say that the coordinates are in X or Y form. Two numbers are there. But in the embedding, and when we store the data in vector database, okay, it is not specific to only two numbers. Okay, it can go up to very higher numbers. Okay, I will explain in the next few slides. Okay, so now here see, this is a word and there is a corresponding embedding for this one, or you can say corresponding numbers for a particular text, like in this form, like there is a queen. So for queen we will have a other coordinates. That means each and every word is embedded or converted into the numbers. So if you see here, sorry, coordinates of the king and the queen, okay, are almost similar. Okay, 0.92 is the first number in the embedding for the king, and 0.91 is for the queen. Similarly, if we see here for dog, the first number is 0.10 and second is 0.09. Similarly, if you see the other numbers, they are also similar, right? So that means these will be placed together or nearest in the vector database because they have a similar meaning. So dog and cat will be the represented by the animals, right? So in the vector database they will be closest. Similar to king and queen will be in the similar meaning. Okay, so they will be closest in the vector database. So that means in embedding, each and every text is converted into the numbers. That means in the embeddings. Okay, and it's not specific to two numbers. There could be n number of n numbers, n number of vectors, or you can say n number of different embedding for a particular text. Okay, and the word with the similar meaning will be placed nearest to each other, and they will have this almost similar coordinates or the nearby coordinates. Okay, Now that means embedding capture meanings, not just word. So when we do the regular search, okay, in our local file systems, in some Word document, PDF document, or maybe in the database, okay, so what we give, we search for a keyword. So that means when we search in the traditional way, it look for the keywords, okay, what the word we are searching. But in this embedding, okay, it doesn't look for the particular word. In fact, it look for the meaning of that word. So once it understand the meaning of that word, it can gather all the similar words or sentences they may be relevant. And that is the major difference here in the RAG. Okay, that means similar meaning will have the similar numbers or embeddings, and they will be nearest to each other. That means similar position in the space, right? So now if you see here, dog, cat, rabbit, they all are animals, right? They belong to animals. So their vectors or their embedding numbers will be almost similar, or they will be nearest about. So all these elements will be stored together at same place. Similarly, when we say about king, queen, princess or prince, okay, so they belong to royalty. So they, all these keywords will be stored together at the same place. Similarly, we talk about pizza, pasta, burger, they all are food. So that means all these items will be placed at the same place. Okay, now suppose that in a traditional searching, you are searching in a file system, maybe in the database or maybe in a file, Word file, PDF file. If you search for food, if you search for food string, it will only look for the food string in your document. Okay, right? If the food string is not there, no result will be retrieved. However, you may have the pizza, pasta, burger, these kind of a text or sentences in your document. So these all are related with the food. So traditional search will only look for the food text, but when we search for the embed via the embeddings and vector database in RAG, okay, it will look for all the related items, and that is the mean what I was talking about. That in the RAG embedding and vector database, it not only just for the words, it look for the meaning of word, so that it can retrieve the related content of that particular text, and this is the main difference in the RAG with comparison with the traditional search. So that means similar thing cluster together. Dog and cat have very similar embedding because both are common household pets, right? Distance similarity. The closer two embedding are in space, the more similar their meaning. We measure this with cosine similarity. So cosine similarity is a term that is used in the mathematics, okay, to identify the two vectors that is nearest to each other. Vector means is like if you see in the previous slide, okay, so we have stored the data like this, okay, there is a square bracket, and then inside that we have written some numbers 1 2 3 4, like something like that. So this is called the vector. Okay, so now if we talk about the cosine similarity in the mathematics, so suppose that we have a vector like this one, and number is 1 2 3 4, something like that, and this is a vector for the queen. Similarly, we will have another vector like 2 6, sorry, 2 6 7 8 9. This will be vector for the king. So these two vectors will place at nearest, right? Because for king and queen, which belong to royalty. So this is called the cosine similarity in mathematics, to understand the two similar vectors and to place them at the right, at the adjacent to each other, right? This is called the distance similarity. Then hundreds of dimensions. So what I said in the previous slide, when we talk about the city map, the map, the city in a map, okay, we have the coordinates in the x and y form, only two numbers. But when we talk about the embedding in the vector database, it's not limited to two words, okay. So this is called a dimension, okay. So that means inside the this square bracket, whatever the numbers that we are writing, 5 6, whatever, okay, this is called the dimensions, or you can say total numbers in a particular vector. Okay, so the real embedding use 768 to 3000 plus numbers, not just two, just like we have seen the coordinates of a city in the map. This capture incredibly nuanced meaning. Okay, so that means the numbers in a particular vector in embedding will not be limited to two, it can be up to 3000 or more than that as well, right? So this is how embedding work, okay, in the vector database. Now, how are embedding created? In a simple way, an AI model trained on billion of sentences learn to convert text into numbers, right? So we know that in an AI model, okay, it is trained on the humongous data, billions of sentences and words, okay, and that learns to convert text into numbers. So that means whenever we have a large number of document, which is your individual documents, your organizational document that we are going to store in the vector database, okay, for the RAG. Okay, so what happened is all these text converted into numbers. Okay, for example, you have 1000 PDF document of your organization, of different policies, legal documents, and different kind of documents. Okay, and you are creating a RAG so that you can provide access to all of your documents. So whenever you run any your custom queries which is belong to your organization, so your RAG can give you the answer of your customized data, right? So in that case, if you have 1000 document, irrespective of the size, maybe the size of all 1000 document will be around 2 GB, sorry, 20 GB. Okay, so what will happen? All these documents data, which is of 20 GB, will be converted into numbers. That means it will be converted into embedding to store in the vector database, because as I said, it's not a traditional search in the RAG. It doesn't will go to look for your specific text in your PDF document. Okay, this PDF document data is going to convert it into the numbers, and whenever we run any of the our query, or we write some query to LLMs, okay, which is going to contact the RAG to extract the information. So the RAG will contact your vector database where all the text is stored in the form of numbers. Okay, so what we do, we simple write a query like I love playing cricket. Okay, and then we have a AI models like OpenAI, Bird, Gemini, Claude. These are the LLMs, AI models. This is called the LLMs, which take your queries. Okay, and then all the data whatever we have in our organizational or maybe your personal data, it is going to store in the form of embedding, in the form of embedding in the database or in the vector database, right? So that means it is important to understand the vector database as well. So what I'm teaching as of now, I'm giving the overview of embedding, how the data is stored in your vector database, what is the concept of that, okay, as of now. So we have the popular embedding models. There are multiple embedding models, okay, we know about that one, made by OpenAI, Google, okay, Hugging Face, Cohere. There are a lot of different popular embedding models are there in the market. And these are the models, specific model of the particular organization which they have released. Okay, and each and every model has their own features and functionalities. They all work in some specific area in a better way, right? And if you see here the number of dimensions created by each and every model, so dimension means the total number of numbers that is generated in the vector form for a particular text, right? This is what we have learned. So now for example, we have a word called city. So this city is going to store in the form of vectors, and inside this vector we will have some numbers, correct? So this keyword or this word is going to convert into the form of numbers in the vector, which is going to store in the vector database, right? So the dimensions or the numbers that is there inside a particular vector, this is a count of same. So that means if you are going to use OpenAI this particular model, so this will convert your text in the vector form, and inside the vector form the total numbers for a particular vector of a text will be up to or exact 1536. So this is the dimensions that is generated by the each and every model. So now hope it is clear to you what is the meaning of dimensions when we talk about the vector database. Now what is vector database? So I have given you a complete overview of the vector database as well. So now if you talk about a generic definition, so a normal database store exact data, right? What we have learned so far, that like whenever we store some content, so in the normal database it is stored the exact data, and whenever we do the search it look for that particular keyword. But when we talk about a vector database, it is stored embedding in the form of vectors and vector in the vector database, and let you search by the similarity. Okay, it's not search the specific word. When we search for a word, okay, it search for the meaning, not about the exact keyword, right? Like the pizza, burger, and then let a lot of foods are there, right? So when we write food, so it can sense and it can understand all the related items with the help of meaning, not about the static search. That is a major difference in the vector database. So that means when we have a normal database, it find exact matches only, right? As I said, if I am searching for food, it will look for only this particular text. Like search cricket, it only find the cricket. fast for structured data. So you have a structured data, right, in the form of structure where we store the data in the form of tables, or we have some standard documents, we have some standard PDF files. So it can't understand the meaning or context, right? This is a major difference. Your normal database or normal search will not understand the meaning of the word. It will only search for a particular text, right? Like we have data in the MySQL, Oracle, PostgreSQL. There are a lot of database are there. If you compare it with a vector database, it finds similar matches. Okay, and like cricket, if you say cricket, so cricket belong to a sports. Okay, and IPL is also related with the cricket, right? Bat is also related with the cricket. So whenever you do a search of cricket, so it, like traditional model, it is not only going to search for this text, it is going to fetch all the text or the section which is related with the sports, with the IPL, with the bat, and similarly lot more. Okay, and it search millions of vector in milliseconds. Okay, so this is a limitation with the traditional database as well, right? If you have traditional database, then the search, if it is a huge amount of data, then definitely the search is going to take a lot of time. But when it is a vector database, okay, there are millions of vectors in the database and it can search in just a milliseconds, because it understands context and semantic meaning. This is the important word what I have been explaining. In the vector database, it understands the context and semantic meaning, which I will explain again in next few slides. Okay, so these are certain examples of the vector database. Pinecone, Wavite, ChromeDB. These are the some examples of your vector database. So now when we say understand context and semantic meaning, okay, so let me explain you with two more examples. Now suppose that in a document there is a sentence called Virat Kohli scored a century in the IPL. Okay, user searches for cricket players. So what will happen? Keyword search may not find it because cricket is not present. So now if the user is searching for cricket players or maybe cricket, so if you see this sentence, there is no cricket word here, right? So traditional search will not return this particular result because cricket is not there. Okay, but semantic search find it because Virat Kohli and IPL are strongly related to the cricket. So now here your vector search will understand, or semantic search will understand, IPL Virat Kohli is related with the cricket. So when we say cricket players, okay, so semantic search will return the proper result. That's because system understand that cricket is related to sports, IPL, bat, bowler, wicket, T20, Virat Kohli, World Cup. These all are related with the cricket, right? So your semantic search can easily understand if user is searching for the cricket, so it's related with the these all tags, right? So your semantic search will look for all the information that is related with the similar meaning, while the traditional search will fail in this particular way. If I search for cricket in traditional way, it will not result any, it will not give a result in this all these keywords. This is the meaning of semantic search. Now second, let us talk about a document. A user is searching for a employees received 24 annual leaves. This is the information in a document. Employees received 24 annual leaves. Now user asks how many vacations are allowed. Now you see these two particular text. How many vacations are allowed? So it is talking about the vacations. In the document, it is annual leaves, not vacations. It's leaves there. Right, so vacation is not present. So if I go for a traditional search, you will not get any result, right? Because the vacation word is not in the database, so it is not going to return any information. But if you talk about the semantic search, so semantic search understand the user written has annual leaves. So leaves, user is talking about the leaves. Leaves is related with the vacation, leave, holiday, time off, and many more keywords. So if you are doing a semantic search, you are writing this query, then definitely you are going to get the result, which is not possible in the traditional search models. This is the importance of your RAG and semantic search and vector database, and this is how it works. Right, now how vector search works step by step. So this is the conclusion what we have discussed so far. Okay, finding similar movie to Inception. I suppose that you wanted to search for all the movies which is similar to Inception, right? So store your data. All movie descriptions are converted to embeddings and stored in the vector database, right? So that means whenever we store the data about the movies, okay, so it is going to convert into the numbers, and this numbers is going to store in the database in the form of vectors, which is a vector database, right? So now, like suppose Inception, a thief who enters dream, and this is the vector for this particular text. Inception, a thief who enters dream. Second, you ask a question. Your question is movies about dreams and realities. Now you have given dreams and realities. So this query is also converted into the embedding. So now your query will convert into the embedding. Okay. And once your query is converted into the embedding, now in the database, your complete data or text is also stored in the form of embeddings. Right. So now what will happen? Measure distance. The database measure how close the query vector is to every stored movie vector using math cosine similarity. So I have explained what is cosine similarity. That means matching the two vectors in the database, closest vector in the database. Right. So now this is the vector of this particular movie which is already stored in a database. Right. Now when you enter the query, your query is converted into the vectors. Now we have, this is the vector, and this need to be compared with each and every vector which is related with the movies in your database, right? And then it will identify which is the closest vector to this particular query vector. Okay, so here if you see 0.79, 0.81, 0.25, 0.23, 0.65, 0.67, they are very closest to each other. So that means by this way it will identify the closest vector and the related text for your query, and then it return closest result. So it result inception, the matrix, interstellar in the millisecond. So this result will be retrieved in the millisecond. So there could be other movies as well which is having the closest matrices, right? Like the matrix, interstellar. So it will return the result to you. So this is how your embedding works. Or you can say vector search work. We store the data in the form of vectors in the vector database with the help of embedding, which convert text into the numbers in the vector form. And then whenever you search any string, or when you run a particular query, when you ask a query, that query is converted into the particular vector, and that vector is compared with the nearest vector in your database. Okay, now let us talk about few real world use cases that will give you the complete clarity. Let's talk about the semantic search. Now you write the Google how to fix headache. Okay, it find result about migration relief even without exact words. So how to fix headache? There is no word related with the migration and relief, but headache is a term that is related with the migraine. So your semantic search will understand the related meaning, not the exact keyword, and it will return the proper result, whatever related with to your questions. Product recommendations. You bought running shoes. Okay, so when you bought the running shoes, okay, when you go later time to log into your account, and then you start searching for the different products, okay, you will get the recommendations. Okay, it will automatically suggest the socks, water bottle, fitness tracker, because it understands the context of your sentence, and based on the understanding it may show you the related context. Chatbot and Rex. So whenever you create a chatbot for your organization or maybe for the public, and you allow this chatbot to the access to your documentation, your personal documentation, your organizational documentations, so that the user get a proper response. Right. So a customer support bot searches your company's knowledge base to find the right answer. Okay, so you give the access to your documentation to the RAG and chatbots. So your chatbots is like an LLM which can talk to you in a simple, normal human language. And then when you write a query, that query with the help of RAG goes to your vector database where all the your organizational data is stored in the form of numbers, and then the relevant result will be retrieved in the milliseconds. Content delivery. You watch Inception. So you watch the Inception movie, but it gives you the recommendations related with the similar movies, right? Like the Matrix, Shutter Island, Interstellar. So these are all based on the searches that you have done. It understands the meaning or context of that search and give you the relevant recommendations. Document search. Search 10,000 contact for clause similar to give example clause. That means a legal firm is searching like 10,000 contract for clause similar to. If you are searching for a similar to clause in the multiple documents, okay, so it can retrieve the information by just understanding the context of your sentence. Okay, duplicate detection. News sites detect if two articles cover the same story, even words vary differently. That means if you have written some stories, okay, and two stories have been written for a same topic but using the different words. Okay, so your vector database or RAG search can easily identify that one. Even they are referring with a different word. They have been written completely different. Okay, but your RAG can identify the duplicate because it understands the meaning of the text instead of only the plain text, just like the traditional search. Okay, so let us talk about few popular vector database. So there are multiple vector databases are available in the market, and each and every vector database have own features and purpose for which they can use. Like we have a Pinecone. Pinecone is a cloud managed vector database. Okay, so this is a fully managed cloud. Okay, great for production applications. Okay, then we have a Chrome DB. Okay, this is an open source. So free, runs locally on your machine, perfect for learning and prototyping. So if you are doing some lab exercises, you are learning the agentic AI, RAG, LLMs, and you want to create your own RAG and LLMs, okay, or to utilize your LLMs, so not to create the LLMs, but to utilize the LLMs and then to create your RAG, okay, or agentic AI. So you can use the Chrome DB as a vector DB for the practice purpose. We have a Waviate, we have a Quadrant, PG Vector, FAISS. So there are a lot of different vector databases are there, okay, that you can learn. Okay, but for testing and learning purpose or in your local system, you can use the Chrome DB. Now putting it all together, full pipeline, building a smart recipe search app. Now you're building a smart recipe search app. Okay, so indexing. So one time setup, 10,000 recipes. This is your data. You have a 10,000 recipes. So you are going to convert the embedding model. So this recipes is now going to store in your vector database, right? So if it is going to store in the vector database, so we need to convert in the embedding model, right? That means we have to convert into the vector so that it can be stored in the vector database. This is a one-time activity. When you initially store your data in the vector database, so your data is converted into the embedding models that in converted in the vectors, and then it is stored in the vector database. Right now, whenever a user search a particular query like spicy Indian dinner. Okay, now here you can see the text is spicy Indian dinner. Here there is no specific recipe is given. It's a very generic statement, spicy Indian dinner. Right now, if you are searching this query in your LLM, okay, the first this is going to convert into the vector, right? And once it is converted into a particular vector, then it is going to search the nearest neighbor in the vector database. Right? What are the nearest neighbor in the vector database for this particular vector, right? And then it is going to return the result which is the nearest one. For example, butter chicken, tikka masala, and many more items which is specifically a spicy dinner in the Indian foods. It is going to retrieve the result, right? So this is how your embedding works, right? So key term what we have learned, embedding, that means a list of numbers that represent the meaning of text. It could be text, image, or audio, right? Every data is converted into the embedding. Then dimensioning is a number that we have in a vector, the total number of numbers that we have in a particular vector. Vector database which is stored to your data in the vector form, right? That means after embedding you get the vectors, and that vector data is stored in your vector database, so which is a special database optimized to store and quickly search embedding vectors. Chunking is called splitting large document into smaller pieces after before embedding each pieces. Okay, so this I will cover in the next some other sessions as well in bit detail. So chunking is a very small, very straightforward process. Splitting large document into smaller pieces before embedding each piece. So now we have a different document, and there could be a large size of document as well, right? So in the vector database there is a limitation. It cannot store the complete document in a same place, or like all the large document in your vector database. So that large document that need to split into the multiple small chunks, small pieces before you convert that into the embedding, and this is called the chunking. To split a large document into small pieces before we convert into the embedding and going to store in the vector database. Vector is very clear to you. This is the vector. This is a mathematical form of a particular text when we convert into the numbers. Cosine similarity I have explained to you, like to compare if two vectors are similar to each other or not. How or you can say we in the mathematical form, we compare the two vectors to understand how nearest they are, how nearest each to they are each other. Okay, this is called the cosine similarity. And then we have some other searching models like the ANN search, so which is called the approximate nearest neighbor. It's a fast method to find the most similar vector. So whenever the cosine similarity look for the vectors which is similar to each other, it use some searches like the ANN. okay, which is a method, fast method to find the most similar vectors. And then RAG we have already covered, retrieval, augmented, and generation, which use the vector search, okay, to retrieve the results whenever we do the searches with the help of LLMs, or whenever we write some queries to the LLMs like ChatGPT, Claude, Gemini, okay, and then it get converted with the help of RAG. So what you have learned today: embedding convert text images or into list of numbers that capture meanings. Similar thing have similar embeddings. They cluster together in the vector space. Similar items at same place. AI models like BERT, OpenAI API generate this embedding for you. Vector database store embedding and let you search by meaning, not exact keywords. The power search engine, recommended system, chatbot, and much more. So now hope it is clear to you what is embedding, what is vector database, and how we store the data in the RAG, specifically in the vector database, by converting that into the embedding or into the form of vectors. Okay, and how it is different than the traditional searching models.